Hello students, welcome to the world of chemistry. This is Dr. Vikram Panchal and I am dealing with spectroscopy for chemistry. This is lecture number 5 in this case. Now in this lecture I will explain you what information is obtained from spectra. So first of all let me explain you motions of electrons. There are mainly three types of motions of any particle, maybe electron or any other particle. The first motion is known as rotation. So if we take this as a center point or center of gravity, then molecule or electron or nuclei will rotate around this like this. And this type of motion may be in the clockwise or anti-clockwise. Okay, so clockwise or anti-clockwise. Rotation is possible. Okay. Second type of motion is known as vibrations. Now, vibrations are related to bonds. For example, if we take H2O, this is oxygen and 2 hydrogen, H2O. Okay. This is covalent bond. You know that. These two are covalent bonds. Then, this molecule may vibrate. So, during vibrations, either hydrogen atoms move away from oxygen or come close to oxygen. In another case, these hydrogens atoms swing back and forth, keeping oxygen as a center. So these are called vibration motions. Okay, and the third one is basically translational motion, in which particle travel in certain direction and reach to another place after some time. This may be due to absorption of energy. So there are three basic motions of particle: translational, vibrational, and rotation. Okay. Now we will see what is the effect of absorbed light on a molecule. So molecule which absorb light and therefore it brings change in motion. Motion of bonding electrons. Some amount of light is absorbed for that, and the remaining is emitted. Is emitted. This absorbed light produce lines. This is the characteristics of spectra, that in any spectra you will observe only lines. Each line indicates certain change in motion of electrons. So, interpretation of lines give us information about internal structure, like types of bond, bond length, bond angles, etc. Okay. For example, we use different types of light for different kind of changes. For example, for us, most important fractions of light are UV, visible, infrared, and microwaves. If we see wavelength of these radiations, then UV begin with 200 nanometer up to 400 nanometer. Then visible light starts from 400 to 750 nanometer. Then from 1 micrometer to 100 micrometer will be infrareds of different regions, and up to 1 centimeter we have microwaves. So here we can see that wavelength increases from UV visible to microwave. Frequency, if we see frequency of UV, it is nearly 10 raised to 16 Hertz to 10 raised to 15 Hertz. Then visible starts up to 10 raised to 14 Hertz. Then infrared is up to 10 raised to 12 Hertz. And microwave is up to 10 raised to 8 to 10 Hertz. Okay. So these are different ranges. Now, if we see energy, as you go from UV to microwave, energy decreases and wavelength increases. So microwave is having minimum energy among these four. So it is having minimum energy and maximum wavelength, and UV visible is having maximum energy and minimum wavelength. Obviously, if energy is less of microwave, it will produce small changes. And if energy is more, then there are different changes in a molecule. So first of all, we will see how microwave changes the molecule. So microwave. Microwaves having minimum energy. And what kind of changes appear because of microwave? Let us see this with two examples. One is HCl, another is HBr. Here in case of HCl, the bond length is different, total mass of molecule is different, therefore there will be different kind of changes. But microwave basically produce change in rotation. So rotations of molecule will be changed due to absorption of microwave. Now this HCl molecule if absorb microwave, then it will rotate. And this may be a center of, here you will find center of gravity towards chlorine. This is center of gravity. While in case of HBr, the center of gravity is towards bromine, more towards bromine. So that is center of gravity of HBr. And both these molecules will rotate, and these rotations will be either clockwise or anti-clockwise. But due to these rotations, this molecule's polarity changes in a different directions, and that will produce lines or wave. So both molecules can absorb microwave of different wavelength and show different rotational motions. But both will give lines of different wavelength. That is due to different bond length, polarity, and mass. Okay. These lines, when we study, we come to know that particular lines belong to HCl, particular lines belong to HBr, and we can identify molecules, we can find out bond length, bond angles, etc. So this way, a group of lines in microwave is known as microwave spectra or rotational spectra, which require minimum amount of energy. So this is all about rotational spectra or microwave spectra. In next lecture, I will explain you vibrational spectra and UV visible spectra. Thank you so much.